So, hi everyone, and welcome to our discussion on oligopolies. And for this video, we're going to start with one of the most basic models in an oligopoly, which is the Cournot model. And essentially, it's the earliest oligopoly model developed in 1838 by Antoine Augustin Cournot. I hope I didn't botch his name, but that's his name. And he's a French economist, which developed this model of oligopoly, in which firms decide on output. So each firm would rather choose their output than a level of price. So we discussed when we tackled monopolies that a firm can only decide either setting the output or setting the price, but they cannot set both simultaneously. So in this particular model, we're gonna set the firms in this case will set output. So for this video, we'll deal with a duopoly case, which is the simplest case wherein there are just two firms in the market. And these two firms produce identical or homogeneous products. And essentially, this ensures that there is a single market price at which both of the firms will sell their output since it's homogeneous good. Because if a firm chooses a different price, all consumers will just buy from the lowest of the two prices since it's a two firm case, and the highest price will have zero sales because it's a homogeneous good. Then, as we said, since this is a Cournot model, each firm chooses an output level rather than price. And we also further assume that the firms choose and announce their output prices simultaneously. So they do that at the same time, which means that each firm's output depends on the market price. But the market price, okay, that market price depends on the total output of the two firms. So that's the output of firm 1, so that's Q1, plus the output of firm 2, that's Q2, to get like the total market output. And it suggests that the market price is not known until both firms have made their output choice. So when they set their output choice simultaneously, then it will be known. And hence, each firm will have to make the output choice. It will have to set output in such a way that it maximizes profit, right? So the goal of the firm is still to maximize profit, but it does this based on its expectation, on some guess, some forecast, or some conjecture of the other firm's output choices, with each firm considering its competitor's output a parameter or a constant. Okay, so that sort of assumption on maximizing profit based on an expectation, it gives rise to a particular concept we call zero conjectural variation. And essentially, this concept states that each firm considers their competitor's output level as a given or constant. So zero conjecture between the firms, which means that how the quantity supplied by or produced by firm 1 with respect to firm 2 and how firm 2 with respect to firm 1 is essentially equal to 0. So in this case, each firm considers their competitor's output level as given. Like they can't do anything about it. So they take it as given. And we also further assume that in this basic case, right, the firms act independently. So they cannot just collude and just divide the profits of as if they were acting like a monopolist, which would be the best case for them. So they act independently without communicating, colluding, or anything. And since they act independently, it means that it doesn't know and it never learns that the other firms also behave on the same assumption. So since there's no line of communication, they do their actions independently, there will be that same assumption going on and on in time about the rivals firms' output levels. And what happens is, because of that independent action, there will be a series of adjustments that will take place in which equilibrium is reached. And we refer to that equilibrium in the Cournot case as the Cournot equilibrium, which we will illustrate using a graph later on. And essentially, this Cournot pattern of behavior implies that firms do not learn from past experience, each expecting the other firms to remain at a given position unless someone adjusts and then there's an adjustment and then the market will clear in and of itself. So we'll discuss that as we get through this video. So to get the concept clearer, okay, so suppose two firms face the same market demand function, which is this one. So that's an inverse market demand function. And it also follows that the derivative of price with respect to Q is negative, which again adheres to the law of demand. But since we have a duopoly case, we have Q1, which is the output of firm 1, plus Q2, which is the output of firm 2, being equal to the total market output, which is capital Q, right? And we let each firm's total cost function be some cost, which is a function of their own output, right? So if you recall, when we discussed a monopoly, we said that the market demand curve is essentially the monopolist demand curve. But this isn't the case when we reach oligopolies. And it's because that the market demand, okay, is not the individual firm's demand curve, but the total demand curve faced by the two firms. So it will be the aggregate of the demand which is faced by the two firms because there's more than one firm in the market. And the individual firm's relevant demand curve, so if you sort of separate the demand curve or break it down or disaggregate it, the individual firm's relevant demand curve is what we refer to as the residual demand curve, which shows the relationship between the quantity demanded of a firm's output and the market price after deducting the quantities demanded of the firm's competitors, because one firm cannot produce everything in the market because this is in an oligopoly. Okay, so to illustrate this, let's start with an example, right? So suppose we have a linear market demand curve, which is this direct demand function. Q is some function of P, which is A over B minus 1 over B times P. And we know that capital Q, which is total market output, is just the sum of the output of firm 1 and the output of firm 2, right? And we can get this expression that this direct demand function is just the sum of the two outputs, which is equal to the function's value here, right? So we can calculate for firm 1's residual demand as since this is gonna be Q1, right? Some function Q1. So that's just Q1 is equal to capital Q minus Q2, right? But we know that capital Q is A over B minus 1 over B times P, right? Minus Q2. And this is going to be equal to, so if we sort of separate it, that's equal to Q1. Okay, so that's the term we've been dealing with. Now, if we want to express it in its inverse form, that is price on one side of the equation and then everything else on another, we can express this as P is equal to A minus B Q1 minus B Q2, right? So this will be the inverse residual demand function for firm 1. So firm 1 inverse residual demand function. Then we do the same procedure for firm 2. So that's Q2 is equal to Q minus Q1, which is equal to A over B minus 1 over B times P minus Q1 is equal to Q2. So if we rearrange everything in the bracket, that will be P is equal to A minus B Q2 minus B Q1. Notice that this one is the same, right? So the price that is charged, right, in the market is the same, and it's some function of the total output, which is Q1 plus Q2. So that should be something that is clear, and it illustrates that the inverse market demand curve, which is P as some function of Q, can be interpreted as either of the firm's residual demand functions. So it can be either this or this, it would yield the same result, right? Because the price charge in this particular market should be the same across all firms, because if a firm opts to charge a higher price, they would lose everything, right? So, and because of the homogeneous good assumption. So let's dive into this concept a bit deeper. Okay, so given this demand curve, so we had this direct demand curve earlier. The inverse demand curve, as we said, is P as some function of Q is A minus B times Q, right? But we know that the total market output is just Q1 plus Q2. So we can rewrite this as this one, which is A minus B Q1 minus B Q2, which is essentially, right, the residual demand function, the inverse residual demand function of each firm. So what we can do is we can sort of formulate the profit maximization process, since we have a revenue and a cost that we can formulate given the with respect to the given. So we can formulate each firm's profit maximization function, which is still the firm's objective. So the firm's ultimate objective is still to maximize profit, of course. And the firm, okay, so if we say we do firm 1, so that's maximize profit, which is some function of Q1, noting that it cannot, it takes Q2's output as a constant, right? The same assumption we made earlier. So it wants to maximize profit 1, right? Which is its profit of firm 1. So that's just revenue 1 minus cost 1. So what's revenue 1? So that's just P, right? The same price prevails in the market times Q1. So this part here is revenue minus the cost function of firm 1. And this would ultimately be equal to P as a function of Q, which is the inverse demand curve, right? Times Q1 minus C1 times Q1. C1, which is some function of Q1. And the FOC for that firm to attain a maximum profit is if you derive profit 1 with respect to Q1 and equate that to 0. And to ensure the maximum, the SOC requires that this form here, if you take the second order derivative test, that should be negative to ensure a maximum, right? So for the FOC, right, so say let's get this, derive profit 1 with respect to Q1, we're gonna get P, so simple product rule here, that's P times Q, plus if you derive Q1, right, times, if you notice, if we take the derivative of PQ with respect to Q1, we need to do a chain rule for that. So that's just going to be dPQ dQ. But we know that Q has Q1 plus Q2 inside of it. So we need to multiply that by partial of Q with respect to Q1. Okay, minus the derivative of the cost function with respect to Q1. So that's d C1 Q1 with respect to d Q1, right? And you'll notice that the first portion here, okay, this entire first portion is essentially marginal revenue, right? Because that's the derivative of revenue with respect to Q1. And this one is marginal cost. And those are marginal revenues and marginal cost of firm 1. Okay, but if you notice something with this derivative in particular, since Q is equal to Q1 plus Q2, so this derivative, Q, with respect to Q1, is just equal to Q1 plus Q2 with respect to Q1, right? And this is the same as by rules of derivatives, that's the partial of Q1 over the partial of Q1 plus the partial of Q2 over the partial of Q1. And if we take the derivative of something with respect to itself, this is equal to 1. Then if you recall one of our assumptions earlier, which is the zero conjecture variation assumption, right, states that the zero conjectural variation assumption states that that is equal to 0. Therefore, this entire term here is equal to 1. So the FOC will essentially reduce to MR, right? So MR1 is equal to P, which is some function of Q, plus Q1 times dPQ over dq, and it's going to be times 1, so that's going to be that, should be equal to marginal cost 1, which is equal to the c1d of, which is some function of q1 over dq1, right? So that's going to be there. And what happens is we get that condition of mr1 should be equal to mc1, which is the FOC for firm 1's maximum profit. And what we can do is we can solve for this FOC, and what we'll get is some quantity, okay, some output response function. So if you solve this FOC for firm 1's optimal amount, which is essentially if you try and solve for Q1 star, if you solve for Q1 star, you're going to find that it's going to be some function of Q2. And this function is known as the firm's output response function or best response function. And this shows firm 1's best response or profit maximizing output for any output chosen by firm 2, which is Q2, right? Because they set their actions independently, they don't collude. And this same maximization procedure applies for firm 2 as well. So if we do the same for firm 2, we could get the output response function of firm 2, which shows firm 2's best response or profit maximizing output, which is Q2 for any amount chosen by firm 1, which is Q1. So the same procedure applies. So we now know the profit maximization criteria of each firm. We can now go to discussing about a Cournot equilibrium. And essentially, it answers the question, how much should each firm produce? And each firm will have no incentive to deviate when they're at equilibrium. So let's discuss that a bit. So the equilibrium output for each firm is essentially when each firm's output is a best response to the other firm's output. Okay, that scenario is a case wherein in equilibrium, each firm is maximizing its profit given the other firm's output. Again, it can control the other firm's output, has no say. And whatever output it will choose, it will be what gives it the maximum profit subject to the other firm's output. And neither firm has any after-the-fact reason to regret its output choice, and thus no reason to change it anymore. So it has no incentive to deviate from this sort of equilibrium. And we preclude this by saying that the Cournot equilibrium is essentially a Nash equilibrium. So some concept in game theory, which is essentially a set of strategies for one player. And we call this strategy a Nash equilibrium if no player wants to change their behavior given the behavior of the opponent. So the same scenario here, the firm has no incentive to change its output given the output of the other firm. And it's output because the firms decide on output and not on price. And essentially, mathematically, this corresponds to the pair of outputs, which is Q1 and Q2, that can simultaneously solve the two firms' reaction function. And it's obtained by substituting the rival firm's output reaction function into a firm's own output reaction function. So that will be the case, and we'll show that in the next video how to do that in a specific problem. But graphically, it looks something like this. So we have here Q2, which is the output of firm 2 on the y-axis, and Q1, which is the output of firm 1 on the x-axis, and we see their best response functions graphed out. The Cournot equilibrium lies here. So let's say this is point E, which means that at the Cournot equilibrium, the optimal quantities for firm 1 is Q1 star, and the optimal quantity for firm 2 is Q2 star. And we'll notice that, for example, okay, say we were here at this point, okay, say this was the point that we had initially, then firm 2 would supply this much, okay, and firm 1 would only supply this much. So this is firm 1. What happens is because firm 1 has an incentive to perform better, what it would typically do is it would try to respond by lowering price. So if it lowers its price, it moves to closer and closer to that equilibrium, and in that equilibrium, which is point E, there is no more incentive for the firms to deviate from that equilibrium. So firm 2 will opt to produce this much, and firm 1 will opt to produce that much. So that's our introduction to Cournot equilibrium and the Cournot duopoly case. And in the next video, we're going to discuss a specific example which I think will bring everything closer together and shed more light on this problem of a duopoly. So thank you for your attention, and I hope to see you in the next video.